Assalamualaikum warahmatullahi wabarakatuh. Today our group will present the product that we have selected in the group assignment team. So the product that we have choose is a rocket body. When many people think of rocket, the first thing that comes to mind is NASA and its space exploration program. When NASA first started creating rockets, they look more like the modern rockets that are built today. These are early rockets that NASA built had all of the vital components situated at the front of the rocket inside the body of the rocket. NASA now uses a completely different system. So today we want to discuss about rocket body and not NASA. They were composed of four primary parts. The four parts are the nose cone, the body, the fuel, and the rocket engine. The vital components are now strapped to rocket in the form of a shuttle. However, the rocket that take the shuttle into space are fundamentally the same as the original rocket. The body of a rocket is one of the more influential parts.
Hi, my name is Ahmad Faris. Today I would like to present about the most suitable combination of materials and processing. There are three materials that we want to choose. There is aluminum, titanium and steel. And I will go through each one of it. The first is aluminum. Aluminum is the most abundant metal on earth. It's also highly reactive. Aluminum is so reactive in fact that it's not found naturally in its pure form but only in combination of other materials. This ability to readily combine with other metals that makes aluminum so useful. Second, the second material is titanium. Titanium is a highly desirable metal in the field of metallurgical engineering, but it is also has a number of interesting of non-engineering uses. For instance, titanium is used in medicine as a bone and cartilage substitute due to its strength, lightweight, resilient to heat, and corrosion resistance. Alloys made of titanium and other metals are employed in place of aluminum in rocket ships, jets, and aeroplanes. The third material is steel. Steel is less frequently used than the titanium and aluminum. Steel is still a powerful element of rocket construction. Steel is roughly 2.5 times stronger than aluminum, while aluminum is typically 2.5 times lighter. Steel is a unique kind of material. To start, steel is an alloy, which means that it is made of iron mixed with other important components including manganese, carbon, sulfur, occasionally chromium, nickel, and titanium. Even before the titanium and aluminum were the preferred materials, steel was utilized in the Atlas series of rockets in the era of 1960s. So, the best materials of the rocket body is we choose the aluminum.
Hi, today I will present about processing and manufacture for our project. There are four major systems in a full-scale rocket. This is the structure system, the pellet system, and the guidance system, and the propulsion system. The structural system or frame is similar to the fuselage of an airplane. The frame is made from very strong but lightweight materials like titanium or aluminium, and usually employs long stringers which run from the top to the bottom, which are connected to hoops which run around the circumference. The skin is attached to the stringers and hoops to form the basic shape of the rocket. The skin may be coated with a thermal protection system to keep out the heat of air friction during a flight and to keep in the cool temperatures need for certain use and oxides. Fins are attached to some rocket at the bottom of the frame to provide stability during the flight. The pellet system of a rocket depends on the rocket's mission. The guidance system of a rocket may include very sophisticated sensors on board computers, radars, and communication equipment to maneuver the rocket in flight. Many different methods have been developed to control rockets in the flight. As you can see on the figure, most of a full-scale rocket is a propulsion system. There are two main classes of propulsion system, liquid rocket engines and solid rocket engines. The V2 uses a liquid rocket engine consistent of fuel and oxides. Tanks pumps a combustion chamber with nozzle and the associated plumbing. Some component parts have to be joined together by some means other than bolts to form an assembly. This is often done by welding, TIG welding, often known as a gas tungsten arc welding or GTAW. See is lot of use. In some instances, electron beam welding, EB welding is used. This process is really neat when it works right, but it requires a good bit of extra care and is a bit lot of trouble to set up. One thing that tend to set the rocket component fabrication apart from more everyday stuff is that weight is important. Weight is an absolute premium in any machine that flies, so every effort is made to reduce the weight of every rocket component to the maximum extent possible.
Hello, I'm Afif. Okay, today I want to be talking about material selection for my group, which is our topic is rockets body. Alright. Several crucial considerations must be made while choosing the best material to create spacecraft. For instance, the choice of materials is influenced by the resistance to heat and cold, their weight and strength, whether they must operate at low temperature for liquid fuel system or at high temperature for combustion. All of these factors play a significant role in determining whether a material is stable for any spacecraft. Rocket ship follow the same rules. However, depending on which area of the rocket the material is utilized, several materials may be used to construct rocket ship. For example, the rocket's body must be light for the spaceship to have a higher chance of escaping the Earth's gravitational pull. Okay, we have first material, which is aluminium. Why aluminium is such a good material for make the rocket's body? First, aluminium is strong. Okay, it's not strong. It can withstand high pressure and low temperature. And second, we all know the aluminium is lightweight. Okay, but we cannot use the aluminium as the rocket's body because of
In conclusion, we can conclude that the operation of the rocket is based on Newton's third law of the motion. Every action is accompanied by an equal and opposite reaction. The rocket is proper in a forward direction when the fuel is expelled from the back of its body. However, there are a few disadvantages of a rocket body. For example, most liquid fuels used in a rocket are dangerous and are difficult to handle. Solid fuel, on the other hand, are easier to handle, but once they start burning, they can be stopped. Nevertheless, rocket explosion can cause much damage to its surrounding. That's all from our group. Thank you.